I'm Alex Sieving. I'm a project architect with AI3, and I began working on the Watertown High School project when it started in 2019, and I was lucky to work on a lot of the interior spaces, which we'll be talking about later.
And I am Samantha Lane with AI3, also project architect. I worked mostly on the exterior of the Watertown High School project. On this corner of the building is mainly the tech engineering wing. We have graphic arts in here, we have the technology classrooms, and we really chose to highlight that space with the use of glazing and these sunshade features to help manage the solar glare, the heat gain. We used 3D modeling to help analyze the actual angles that the sun was going to be hitting this wing and how we could protect those internal classrooms with the use of the sunshades here.
You're looking at what's going to be the solar canopy on top of the roof, and below all that steel that's framing the sky is the HVAC equipment. And the great thing about having the solar panels up there on the canopy is they're going to shade the mechanical equipment, so the equipment will perform more efficiently, last longer, break down less often, so it's just a win-win.
We use two different mechanical systems as sources for heating and cooling the building. So we used air source heat pumps and ground source heat pumps. And that was to just maximize efficiency of ventilation throughout the spaces. And it also helped reduce the amount of equipment that was on the roof there.
On this particular project at the Watertown High School, we are utilizing energy recovery units, which are taking water through the geothermal piping that's going to go down into the ground and utilize the Earth's natural temperature to temper either heat or cooling respectively. We'll take the exhaust air that's circulating from inside the building out, and we'll use the means and methods inside this unit to temper the return air coming in, call it preconditioning, so that the unit doesn't have to work as hard and it makes it more energy efficient. But I believe there are 12 of them. 4 of them have geothermal piping going to them, so only 4 of them are actually getting water source. And the piping goes down into the mechanical room, gets pushed throughout the building by use of the pumps, and then filters down into the ground in a closed loop system and comes up. And again, depending on what desired temperature you're looking for, heating or cooling, you can achieve that through the Earth's natural properties, which is kind of cool.
This is where we produce our hot water, and it is coming from another room out in the basement. And we also have another hot water room up in the roof. We have 2 big water tanks. This is normally abnormally bigger, that I heard, than our normal ones, but what produces our hot water comes in from the top, and it heats up inside the tank.
We're standing right in front of a geothermal well field, so all of this mud is going to be beautiful grass. I think there's probably about 4 or 5 wells right here in front of us. There's some around the corner too. They went down over 800 feet. And that's just a giant heat sink and cool sink. In summer and winter, we'll be taking advantage of that constant 40-degree ground to get the temperature where we want it to be in the building. So these are closed wells, which means that there is a closed sealed liquid that's not going to leak into the ground, and groundwater's not going to leak into the wells. But that liquid is going to thermally exchange its temperature with the ground temperature. So in the summer, the liquid will pick up heat as it flows through pipes in the building, go down into the ground, get cooled down to 40 degrees, and bring that 40-degree cooling into the building. And in the winter, it's the opposite. The air might be 20 degrees, the liquid will pick up that temperature, carry it down to the ground, pick up the warmer ground temperature, and then we do have to use a little bit of energy to boost and concentrate that heat from 40 degrees to what you want coming out of a duct to heat the building. But it's far more efficient than using the air temperature to warm up. Over the lifetime of this building, they will save hundreds of thousands, if not millions of dollars in energy costs. This is the first LEED Platinum Net Zero high school in the nation. Watertown is a leader in green building, and especially for the schools, so it's just fantastic. Geothermal well technology has been around for decades, but they've been getting the kinks out of it. And so this is a great time to be adopting it because the problems have been solved, the technology is sound, and the hardest part is the drilling, and that went really well on this site.
We were able to cover more of the rooftop with the PV systems to, again, help get the energy from the solar panels. And then we also maximized efficiency throughout the building envelopes. Again, we used that 3D modeling and energy analysis to determine the makeup of the exterior wall assembly. And that really determined the thickness of the insulation, the proportions, the amount of the glazing versus solid on the exterior walls. And all of that really informed the entire design of the building, where we do have highlighted glazing, and where we do have more of that thicker insulation on the roof and on the walls.
So we're working here at the Watertown High School. It's a rain screen system that Capasso is actually installing. We're using ultra high performance concrete panels. They are being produced by Enville. They have a few different textures on this building. They're using 3 different textures: a smooth texture, a flamed texture, and a heavy blast. That's what's giving us the different looks of the face of the panel here. So along with those textures, it gives 3 different color variations with the red. Each texture has its own color variation. We're going to have gray panels as well. There's going to be 2 different color variations of those, but also 3 different textures. Going behind the panels here, we have the AVB system on the wall. And after that liquid system is sprayed on, we come and install what's called a strong girt. It's a fiber girt that is made pretty much out of fiberglass. Sometimes there's a metal band in it, sometimes not. Then after that's installed, we'll insulate with clad stone insulation. It's a very compact insulation system. And then after the insulation goes in, we have aluminum rails that will go on to the girt system with a shim, and then the panels are installed onto the aluminum rails. We also install the trims on all the windows, the flashings on the bases here, and around any openings we also are responsible for. The screen's also going to help, obviously, with the rain screen system being open, birds and insects from actually taking insulation from the wall, because that actually happens over time with some of these systems. So it actually helps keep everything secure and safe from the elements as well. I just love everything about construction. Personally, for me, I enjoyed getting into it because I liked all the machines and being able to go up high in the air. I was sort of an adrenaline junkie when I was younger, so just that aspect of it kind of drew me in. But then I started getting more into the precise details of the projects. I started really enjoying trim and the finer details to really make the project pop, you know, because I enjoyed doing the siding and I enjoyed doing the roofs, but it was really the stuff that brought the project together at the end, that detail work, that was really interesting to me. And there's nothing more exciting than driving down the highway and your kids are in the car with you and their friends and they're like, my dad put that building up, my dad put that building up.
We're at the south side of the building now, which is the academic wing. So we're looking at the classrooms over here, and then looking through these windows into the stairwell and the atrium space. So the design behind this kind of back half of the building was really a compact footprint for the classroom layout in order to maximize building efficiencies and give more space to the site for more outdoor learning spaces and lunch areas and outdoor fields.
We were able to really work with the neighborhood, especially on Columbia Street. The residential houses are so close to the building, and with the natural slope of the site, you know, the building goes from a 2-story to a 4-story building. So, you know, the close abutters, you know, still get to keep that smaller scale residential feel, and clearly, you know, this is a very monumental portion of the building, but it's not placed to interfere with any of the cozy houses around here that are so beautiful. So here we are in the Library Media Center, and it was really important to the school to have this be a central focus of the academic zone. So We've got academic wings to the right and left, and we're centered kind of above and below us with the classrooms, with stairs connecting all of the classroom zones to the media center really well. As you can see, this is a double height media center, so we have stacks above and below, a lot of flexible workspace, also space for classes to actually meet in here and collaborate.
I'm David Helms with United Steel. Been working as an iron worker for 5 years. We do all the miscellaneous metals, so all different stairs, railings, anything small metal basically. I like it because it's something new every day. It's always something different, like this radius stair. It's not always the same thing. You get a lot of challenges, like figuring out how to get things to fit in when not everything always works to plan, so you gotta fix stuff on the fly and get it to work. So it starts with the architect. They'll design the whole stair, how they want it to look, and the engineer goes through, look through it, and make sure it works. And then our shop gets all the drawings, fabricates all the pieces, sends it out here, and we install it. Comes in multiple pieces that we all put together. So you can see in the center there where it's painted, that's where they met. Once more of the finished work's done in here, we'll come and do the stainless steel railings, which those will just get hangers, brackets get screwed into those little posts, and then the rail will get welded or screwed in on top.
This is the art classroom. I worked on this room. I can't believe it. So this wall is where the pottery wheels will be. White tables for tracing along this exterior wall here.
Now we're at the top floor of the school looking at the 4-story atrium. So this connects all 4 floors of the building, letting natural daylight in from the windows at the top all the way down to the classrooms at that ground floor. The space really just opens up the entire interior of the classroom wing and connects all of these different learning spaces between the different floors. We have bridges that connect across the different classroom areas.
The other great thing about this space is that, and this is so important for high schools with a large student population, is the dining. The scale of the dining is broken up. So there'll be dining tables in the atrium spread throughout on this side, and then you have the main dining area and then outdoor dining, so that it's not so zooey, and people can choose the space that kind of fits their mood when they want to eat with their friends.
In the center here, we have the main learning stair. So that's a zone that's going to be very collaborative and interactive, and that's right in the center of the building and right across from the media center and fabrication spaces. So one of the big parts about designing this building is coordinating with the other engineers on the project. So we have structural engineers, electrical, mechanical, plumbing, and all of them are working together to create these more complex spaces like this atrium. So we need to think about how to correctly heat and cool the space, how to structurally support all of these bridges, and how to safely protect with fire protection all throughout this core of the building, but throughout the whole building and throughout the whole design process.
So we're on the 2nd floor, and we're installing porcelain tile in the corridors. Basically, there's 3 different size tiles. There's 8 by 48, there's 8 by 24, different colors. We have to cut it to follow the print. Some sizes we have to cut in half, some we have to trim. And basically we're just laying everything out. It's on a third of a pattern, but it's a puzzle, and you just gotta keep checking to make sure you continue with the right pattern, or it sometimes doesn't look right.
One of the things that I like to tell people about architecture is it's more than art and design and making buildings beautiful. It's a field that really brings in a lot of different aspects and skills and communications. Sometimes I tell people we spend more time making the building safe than we do making it beautiful. We designed the building to never have a fire, but if it were to happen, the sprinkler system would quickly put it out, but we still have backups and backups and backups of safety. So for example, This large strip of metal you see across the wall here, that's going to be a receiver for a smoke curtain. So in the event of a fire, these horizontal shutters would come across and close the atrium to prevent smoke from spreading throughout the building. It would limit it. This entire wall on the left side of the atrium is a 2-hour fire-rated wall, fire-rated windows into the fitness center, and so basically the building is separated into zones to contain any risk or hazard that may happen. But again, you know, we're designing for the worst case scenario. This is a safe building.
This is a design feature that was working with structure. So this is a brace frame that's actually bracing the structure of the building. But with working with the structural engineer, we were able to create this more of a design element and include the Watertown logo and really personalize it to work with the space. I mean, it'll be cleaned up and painted, but that's like final condition. We're going to be able to see that. So we'll actually be able to experience the structure while just walking through the space.
One of the things that's really different about a large building like a school that holds a lot of people is there are higher standards for air quality and ventilation. You can kind of see where the ceiling is and then see there's so much space above it. What's going on there is we have air ducts, we have mechanical piping that's bringing the cooling pipes with colder or warming pipes with warm water that are then air is blown across to heat or cool the room. And there's occupancy sensors that determine how much carbon dioxide is in the air. So if there's a lot of students in here and they've been breathing for a while, it's going to demand more fresh air brought in. If the room's empty, it's going to know that, and it's going to kind of not shut down, but greatly reduce the ventilation. So you just have really great air quality in here. It's good for focus and concentration and well-being, health and safety to always have the right levels of fresh air. And that's why we see just so much space up there.
As you can see, all the blue pipe in all of these labs these are the vents, and then these are the plumbing, and the blue, it's for the acid waste, so it doesn't get just directly mixed in with the regular sanitary waste. And so these individual filters that are underneath, they're basically just filled with limestone. They probably change maybe once a year, depends on how often you use them. But rather than in the old schools, you had a huge vat somewhere down in the basement that would collect what came out of the acid waste. So what this does is filters it, and that way it then goes into the rest of the stream and then can be mixed because it's clean and it goes out into the regular, the water.
Another thing that came out of communications with teachers and administration and students and talking about the curriculum was making the science labs really thematically tied to the curriculum. So we're in a biology lab right now, and you can see there's going to be lab stations around the perimeter, but this is going to be a special corner of the room. This will be kind of the greenhouse corner. There'll be greenhouse shelving to hold plants, soil trays for potting, and really great opportunities for students to do hands-on science right here in the room.
So now we're in the engineering technology classroom. So this is at the corner of the building with all of this glazing and views out. We're seeing the exterior sunshades from the inside now. So these are going to help from overheating this classroom or getting any significant sun glare while they're in here working on computers, working on different surfaces that would be affected by that. So this wall is the north wall, and then this is the west. We have the vertical sunshades on east and west walls so that because of the arc of the sun, those are the surfaces that are going to get the most impact from solar heat gain or solar glare.
And in this hemisphere, you will never see sunshades on the north side of a building. You've got to go to Australia for that one. One of the great things about this building is that there are so many opportunities for students to design and make at all levels. In this space, because of the type of equipment, you can see there's a duct here to evacuate any fumes from the laser cutter. And also a lot of transparency, so classes can be happening, but students can be in here too, or they can just kind of glance over and see where their project is at, where the progress is on the machine. So everything is just super connected and visible. We're standing in the graphic art classroom. In this classroom, there will be kind of a digital work zone and a lecture zone, so you'll have a lot of computer workstations. Designing a darkroom is actually a lot of fun because what you don't see here is the universal accessibility. So anybody can get into this room, maneuver and work. The heights and spaces, you can turn a wheelchair around in here, so it really is a universally accessible room. You can pull up to this sink and use it. And the other thing that's great about this space, because it's a dark room, it has to be dark. So this entry is designed as a light lock, and that's why there's 2 doors. So you're never gonna mess up somebody's work, and there's actually like indicators to tell people like, don't come in, don't open it now.
I'm Lori Suave, and this is Nick Girasol from, we're both from Vertex. We're the owners, project managers on the job site. We're here every day. Unfortunately, today's Nick's last day. He's a student from Wentworth, and he's been a great intern here. Our jobs as the OPMs on the site is just to understand the plans and what the architects are looking for, and just keeping an eye on seeing, you know, that things are moving along with the contractor, that everyone's questions are answered and things are getting built the way that they're intended.
So I'm Nick Girasoli. I'm a junior at Wentworth, and Wentworth has a great program where you can get in the field, you know, right off the bat. Last summer I was working with Vertex, and I'm here again this spring. So I'm studying architecture, so it's been great to be on the field and, you know, really learn a lot more than I probably would have in class on the construction site.
A gym usually is an enclosed space with, you know, maybe some high windows on one side. So this is a really unique space, I think, in that the north and east curtain walls that are in just bring the amount of daylight into the space of the gym, as you can see, which is it's going to be a beautiful space when it's completed.
Being on the northeast side is kind of ideal for the gym because you want it to be on the coolest part of the building.
Right.
So this is only going to get a morning sun, and you know, it'll just stay cooler the rest of the day.
And again, to what Sam was talking about earlier, you have these exposed cross bracing that'll be painted, and again, a good open visual for the students. We have the climbing wall that's been installed over at the other end. It's under protection right now. They're just putting in, you see all the fire-rated wood backer board that's going behind the drywall. You have these beautiful railings around the walking track, so when there's a game on, people can also be up here watching the game. The bleachers are beyond this side. This is where the main court is, and then the practice court is down on the other side in the other direction. So those doors actually go out to the sports court. So that is where the ping pong tables are going to be. There'll be some seating areas with plantings and just a really beautiful outdoor space that's accessible directly off of the gym.
When you see so many doors in the gymnasium, that's another safety feature. This room can hold a lot of people, and we want to get a lot of people out quickly if we ever needed to, which, you know, we hope never happens, but again, we're prepared. You design a building for the worst case scenario, so there's just so many doors, so many double doors. Early in the visioning for this school, they wanted it to be a space for the community, a space to bring the community together, and when we talked about the sport court, people said pocket park, you know, and so after hours, with the plantings and the features, it's a place that anybody can come and relax and enjoy. We're here in medical assisting. One of the great things about this room is, you know, there's a lot of visibility into the space, so you can see this, you know, wide open door, with side lights, so people coming down this corridor will be able to see, hey, there's something really cool going on in here. This is kind of a flexible lecture and learning space. There's 2 medical assisting classrooms, and then kind of the practical patient spaces on the other side. And in between we have the prep room. They won't be treating people here, but it is set up like a clinical setting. And so in here, you can see on the wall these cabinets. These are going to be 1, 2, 3, 4, and around the corner a 5th patient station. So there'll be beds, sinks, cabinets, blood pressure cuffs, scales, all of the things that you would use every day when you're taking in a patient and starting an exam. So again, you know, fantastic hands-on real-world experience in high school. So we are standing in the culinary classroom. This is on the lowest level of the building, and it's directly connected to the atrium. It's a great space for the students. It gets lots of natural light. So this culinary space is going to have, I think, like 8 cooking stations for students. Table seating, they can be both prep table or seating for instructional use. Large video display and a teaching cooking station, you know, with a camera on the stove, and then projecting onto the screen. In the back corner, you have your dry storage for food and supplies. On the left, you have the washroom where everything gets cleaned and sterilized. This is not a licensed food service space. That is what the kitchen and the cafeteria is. However, everything was done in here that if they ever wanted to get a serving license, they could. We're in the wood shop now, and we've kind of been talking about all the different hands-on spaces in the building for students to create things. The Fab Lab, the Engineering Technology Lab, and now we're in the wood shop. And you know, here's where you have several different scales of creation going on. I'm standing under this massive duct, and this is there's an entire ducting system in this space to take dust and sawdust out of the air and send it out to the dust collector. Here we have storage for large lumber coming in, can be delivered into the parking garage, out of the rain and snow. The lumber will never get wet, and it'll go into the storeroom with storage racks and ready to go for the students' projects. So I could see a student here that likes to work with their hands but likes to design on computers, creating custom items that, you know, kind of support all of the biotech and other creative industries in the Boston area. So it all starts here.